you've just started watching this video. You might close it in a few seconds. That's a possibility. Or you might watch it until the end. That would make me happy, of course. That's also a possibility. But here's the strange part. These two possibilities could be happening simultaneously in different universes. I'm not the one saying this. This is a theory proposed by American physicist Hugh Everett in his doctoral thesis. And it's not new yet. Everett thought of this way back in 1957 and said, at every moment of choice, the universe splits into branches. Just like the branches coming out of a tree trunk. When we make a choice, the alternative to that choice might be happening in another universe, that is, on another branch. What I'm describing sounds a bit like quantum physics, doesn't it? But there's an important difference. In the classic interpretation of quantum physics, an electron can be both here and there at the same time. I'm sure everyone remembers Schrödinger's famous cat. That poor cat went through so much. But anyway, what was that thought experiment? A cat, a radioactive atom, and a mechanism that releases poisonous gas are placed in a closed box. If the atom decays, the mechanism is triggered and the cat dies. If it doesn't decay, the cat lives. According to quantum physics, until the box is opened and an observation is made, the atom is potentially both decayed and not decayed, so the cat is both dead and alive. When we open the box, the cat is reduced to a single state. This is called the collapse of the wave function. In other words, a single outcome is chosen from the possibilities. But Everett says the wave function never collapses. Moreover, there's no need for it. At the moment of observation, the system simply splits into different branches. So the cat is both dead and alive. Both are real, but each one happens in a different universe. In fact, the observer also splits in two. One observes the dead cat, the other observes the live cat. So when we look at the box, we find ourselves in one of these branches and experience the reality of that branch. However, no universe interacts with another. Imagine a cinema complex where all possible scenarios are shown simultaneously in different theaters. According to Everett, we are only watching the movie in one of these theaters. We have no idea what's happening in the other theaters. Of course, back then, this theory wasn't taken very seriously. But the topic came up again later, especially in the 1970s. Physicist Bryce DeWitt popularized the theory under the name many worlds. In popular science, the terms multiverse or parallel universe are also used. These are conceptually very similar terms. Bryce DeWitt also wrote a book called The Many Worlds Interpretation of Quantum Mechanics. In fact, this book was published together with a copy of Everett's thesis. Do you know what DeWitt said in that up? In quantum mechanics, all possible histories of a particle are real, just as the cat's dead and alive states are simultaneously real. So the version of you that watches this video to the end is real, and so is the version that closes it in a few seconds. According to DeWitt, all of these happen in different universes. But we only experience one of them. Remember the tree metaphor? Our decisions were splitting into branches, right? Well, according to the theory, our consciousness flows along only one branch, and we experience the reality of that branch. This view completely challenges the classical interpretation of quantum physics. So, was this idea forgotten over time? No, quite the opposite. Even today, some of the most modern interpreters of quantum physics strongly defend this theory. One of them is the British physicist David Deutsch. In an interview in April 2025, he explained the philosophy behind the many worlds interpretation and argued that it is not only the best interpretation of quantum mechanics, but the only logical explanation. For Deutsch, calling the multiverse an interpretation is like calling dinosaurs an interpretation of fossils. So according to him, the multiverse is not an assumption, but a direct and inevitable consequence of quantum mechanics. He wrote an article in 1985 on the subject. In that article, he talks about the ability of quantum systems to perform many calculations in parallel at the same time. I want you to pay special attention to the word parallel here. I'll explain why I want that in a moment. Deutsch was the first to establish the mathematical foundation and theoretical framework for quantum computers. In his 1997 book, The Fabric of Reality, he uses the following phrase: "If one day we can build a universal quantum computer, it will be the strongest proof of the many worlds interpretation of quantum mechanics. That is, the existence of parallel universes. The strongest proof." Now, keep these words in mind, because in the later minutes of the video, I will give a current and very striking example on this topic. American cosmologist Max Tegmark is also a fervent supporter of this theory. He says if the equations of quantum mechanics are correct, then our copies in other branches must also be real. In 2003, he proposed a framework in which he classified parallel universes into 4 levels. Now, I won't get into these and cause too much confusion, but in short, Tegmark not only claims that the universe branches into different universes at every quantum event, but also says that this is testable in principle. He, just like David Deutsch, refers to quantum computers. He says, "I trust my theory, but if a large quantum computer in the future shows that quantum physics doesn't work as we expect, this could falsify the many worlds theory. Then I would be wrong," he says honestly. So he's actually placing the theory within a scientific framework. Theoretical physicist Sean Carroll also describes the many worlds as the purest form of quantum mechanics. In his 2019 book, Something Deeply Hidden, he added a new dimension to the quantum physics debate by defending the idea of many worlds. In an interview he gave this year, he said his belief in many worlds was around 95%. But for him, the most important thing is not the existence of many worlds, but the consistency of the quantum physics at the core of this theory. In other words, if we accept the fundamental mathematical structure of quantum as it is, many worlds emerge on their own, says Carroll. To support his theory, he gives a striking example. 5,000 radioactive decays occur in our bodies per second. According to Carroll, this means that as many as 2 to the power of 5,000 universes are created per second, even in the human body, which is a huge number. Could there be branching universes? Or is this just a matter of physicists' imagination? German theoretical physicist Sabine Hossenfelder is one of the strongest opponents of this theory. She also has a YouTube channel, by the way. I try to follow it as much as possible. Hossenfelder says this theory is unscientific. It's unobservable and unnecessary. Besides, she says we have no chance to test it. In other words, she's one of those who says, "I won't believe it until I see it." According to her, the many worlds theory invents extra unobservable copies for a problem we assume nature has solved. So it's like saying there are invisible elephants in a room we've never seen, but they ran away. Hossenfelder sees people's tendency to believe in multiple universes as a kind of search for consolation. The idea that maybe I'm unhappy in this universe, but there could be a happy me somewhere, is indeed a thought that can comfort us all. Sabine Hossenfelder says this can be dangerous and emphasizes that we should spend our energy solving the problems in this universe. So she's moving the discussion from science a bit towards philosophy. American theoretical physicist Lee Smolin is also on the opposing side, meaning he's one of those who completely reject the theory. According to him, inventing infinite universes under the name of reality is not a scientific but a fantastical approach. Smolin says that such discussions resemble personal beliefs more than physics. Nobel laureate physicist Roger Penrose also offers a rather critical perspective. According to him, this is just a superposition. In other words, there's no such thing as branching universes. There are split states of consciousness in a single universe. Penrose says that to make sense of multiple universes, a separate theory of consciousness is needed. He asks, if everything is happening at the same time, why do we experience only one thing? And it's not an unfair question, actually. In my research, I saw that philosophers also join the discussions. American philosopher Tim Maudlin opposes this theory. He emphasizes that the fundamental question in the measurement problem, which outcome do we actually get, remains unanswered. According to Maudlin, the many worlds theory doesn't solve problems, it just postpones them. So, in short, the scientific world is divided on this, as it is on many theories. This is something that's part of the destiny of modern physics. Ideas that cannot yet be tested are either refuted over time or create a revolution. But if you're pushing the boundaries like Hugh Everett or the scientists who followed in his footsteps, you have to be prepared for rejection. Because, at least for now, we have no way of concretely testing this theory. Consequently, getting these ideas accepted is not that easy. So, could this idea be tested one day? In other words, can the existence of parallel universes be scientifically proven? Last year, in 2024, Google introduced a new generation quantum processor called Willow. And according to the company's claim, this processor solved a problem in less than 5 minutes that would take even today's fastest supercomputers about 10 septillion years to solve. Do you know what Hartmut Neven, the founder of the Google AI Quantum Lab, said? This performance supports the idea that quantum computation happens simultaneously in many parallel universes. So, according to Neven, when quantum computers compute, they act as if they're processing each possibility in a separate universe. Because according to him, this speed seems inexplicable otherwise. Do you remember the connection David Deutsch made years ago between quantum computers and parallel universes? What did Deutsch say? If one day we can build a universal quantum computer, this will be the strongest proof of the many worlds interpretation of quantum mechanics. 40 years after these words, the Willow chip was introduced. But is that really the case? I mean, does the Willow chip use parallel universes? It's hard to reach a clear conclusion, because it's not something we can just test. At least for now. That's why in the scientific community, this explanation is still considered speculative. Yes, many physicists agreed that Willow's performance was impressive, but they think that parallel universes are not necessary for this. They're saying the speed can also be explained by fundamental quantum phenomena like superposition and entanglement. Also, some have commented that Google is trying to get attention in the tech world with these kinds of claims. So it's quite a controversial topic. Maybe one day quantum computers will be able to test parallel universes. We don't know. But while watching this video, you've probably asked yourself this question. I did. If every possibility happens in a separate universe, then do our choices, our decisions, really belong to us? What about free will? If all the branches of this tree are real, why do we only experience one? If all choices are already happening, are we really making a choice? Now, let's pause for a moment and imagine ourselves in the trunk of this tree. Let its roots belong to our past. Let its trunk define who we are now. We have a potential of infinite possibilities leading to each branch. On some branches, we are cowardly. On others, we are brave. On some, we are full of hate. On others, we are full of love. The parallel universe theory says that with each choice, we move towards only one of those branches. So, are we just the sum of our choices? Or are we the consciousness itself, growing in the trunk of that tree, carrying the potential of all those branches? Aren't the branches we don't choose also a part of the tree? Don't the possibilities we give up, the doors we don't open, also shape who we are today? Perhaps this is what free will is. To be able to consciously decide on which of those infinite branches we will take root. But for this, we need the sun, that is, an enlightened consciousness. Maybe we can't interfere with other branches, but we can bring light to our own branch, to this universe.